Okay. Exponentials and logarithms. We don't have a lot of time to go in depth into that, but you already have at some point in your life. Here is the homework. Share so I can record. Yeah, okay, so starts out with a word problem, but nothing crazy. Just says, for each year t, the number of trees in a forest A is represented by that function. Forest B is represented by 8. Then you want to know what's drawing faster. What is the faster rate? So if you remember what the number in front of it, 115 and 88. You guys remember? What happens is that'll be time zero. Okay. What happens is what is negative 0? 1. Right? Negative 0 to 1 is 7. 0. So if you put time 0 means the starting point with the differential 1, draw the differential 1. But at the beginning of time 0, you have this thing. So the number in front represents your starting time. Okay. In this case, how many trees like it is. So growth is affected by definitely the size of this thing. It's bigger. That bottom is bigger. That means the rate is faster. Okay. Although the top one has more trees at the beginning. So for a while it'll appear to be bigger, but in reality this one will catch up eventually and pass that faster rate. Which pop, so all you gotta understand is what does that number mean? How do you tell which one's on that? Well, MPB is the number inside. Which force has a greater number initially? Hey, so if you know what each piece means, you should be able to answer the question. Initially, how many trees the larger forest seed is not smaller forest? Oh, so initially, meaning at the beginning. How many more trees A has than B? Yeah.
It would be different, so 115.
Yeah, basically. Not a difference. Nothing strange. Excuse me. Okay, so first 3 parts, no big deal. Does that make sense? Number 4. Which forest will have a greater number of trees after 30 years? So just plug in 30 for your time and put in your calculator. Which one's bigger? That's all you gotta do. Because T is time. So this T up here is in years. They tell you at the beginning for each year T. So plug in 30 and you'll find out which one's bigger. Okay. And then they'll ask you, okay, well, after 30 years, how many trees will the larger forest exceed the smaller forest? So they want to know, once you put in 30 into both, what's the difference? It's a tree difference. All right. Any question number 1? Is that straightforward? I don't want to work too much on these because we don't have a lot of time. But let me know. Yes. 5? Mm-hmm. For 5, you plug in 30 into both. And just find out how much each one has. What's the difference? What is the tree difference between forest A and forest B in 30 years? Hopefully at that point B has surpassed A. I think probably will. I would bet money it will. Okay. Number 2. Consider this equation. Notice the power is negative. And that is, when you see a negative power, that means your whatever we're talking about is no longer growing. It's decaying. Usually you see that with like what's the famous common example would be like nuclear isotopes in chemistry, and they start to decay over time, like plutonium, etc. Eventually they go into, they change into lead, right? Over billions of years. So you see this, it's decay. Doesn't have to be radioactive, it could be anything. Just dying out. We have this starting amount, 4982. And over time, it'll fade out. R value they're talking about is the growth rate. So the R would be right at negative 0.94. So just look at it. Answer the question. Let's see what these questions are. So that guy would just plug it in. Oops, forgot. All right, click here. It turns into a real question. Can I click this guy? Yes. So what type of change does it represent? Is it growth or decay? Or is it neither? So if it's negative, you make your decision. Okay. Okay. And if you plug in numbers, you'll see it. As you plug in bigger and bigger T numbers, years, you'll see the output's getting smaller. So it'll be obvious. Because R is less than 0. The rate. All right. Now, if you look at number 1, see how this is an e to a negative power? Over here we had some number to t. If this number inside is less than 0, or I'm sorry, less than 1, like if it's a fraction between 0 and 1, then it's decaying as well. Okay, so here it's bigger than 1, right? 1 point something, 1.025. If those two numbers are bigger than 1, it will be growth. Or if you have a negative power, it'll be decay. If it's positive, it will be growth. Right? But the E type questions are easy to see. Okay. So number 3, same question, just what is the R? What does it mean? Is it growth or decay? Number 4. They legit just want you to plug in a number. Just see what happens. They're testing to see if you remember the function notation, like what does f of 9 mean? But also, do you know how to deal with values as powers? And that's all they want to see. Okay. I'm just refreshing you because you're going to be dealing with this stuff in Cal 1. They'll assume, they're going to assume you're good at algebra and you're comfortable with all your functions. Like your exponential, your logarithms, all that stuff is assumed. And if you struggle, you're going to have to review. Okay. People who are pros at algebra, they think calculus is super easy. People who are not think it's the hardest thing ever. Okay, so you just got to improve that skill. And it's about practice, like I said on day 1. Number 5 here, same thing. Plug in -5, see what happens. Okay. This is, I think, predator-prey model. It's pretty, let me see. Population. It's just a regular growth. So basically what they do, you use the general formula. This one up here. Where is it? This guy, see that AERT? Use this and fill in the blank. So A is starting amount. So in that question, A is the total foxes I think you start with. And you gotta solve for the rate. I don't think they give us rate, right? Go back to the Fox question. No. Wait. Growth rate of 9%. Looks like we do. So they give us rate, they give us starting amount. You just plug it in, you should have the function. Yes. Yeah, always use, no matter what you're doing, it should always be converted. 0.09. How do you convert 9 to decimal?
Oh, it doesn't.
Well, not, what does percent mean? Like we hear that all the time. What does percent mean? Something we take for granted, right? It means out of 100. So 9 out of 100 is technically what it's saying. So 9 divided by 100 is the same thing. So 0.09. Does that make sense? So whenever you hear it, that's what they're technically saying. You could actually say, we could say that the symbol means this, we didn't forget because we use it all the time. Anyway, always change it because you can't use the 9. Okay, this right here is ideas about transformations. I think we talked about it a little bit. Yeah, we did review when we had the trig function, but they move up or down. So everything is the same for any function when it comes to transformation. If it's shifted down 8 units, that means there's a -8 outside. Shifted to the left, that means there's a +3 inside of the end. Reflection would have to have a negative in the front. It should reflect the panel. Reflect this way, you have to have a negative inside the column. Right there. I think I sent you notes on transformations. Anyway, so apply those same ideas that we did to trig functions, same thing, just put on an exponential. Okay. They all look the same, they have this kind of shape, right? So I do -3 comes down, -8, +8 goes up. If it's inside the argument, it'll be this way. That's all. Nothing new here. As far as domain, you can plug in whatever you want. Exponential does not have restrictions. So it will always be all real numbers. Range will depend if it's shifted or not. If it's not shifted, it will always be above 0. But if it's shifted down, then we'll have a lower starting point. Okay, if it's shifted up, we'll have a higher. Yes. Well, they said at an interval, so you would put negative infinity comma there. Okay. Graph stuff. I think that's it. Are there any questions in general about because the exponentials are different bases? Any questions about exponentials? Dave, do you remember them? Any things that concern you? Is it okay? Here's what I was saying by vertical shift, it's outside. It's going to be the one that moves up too. And so this guy. If it is in the power, see how it's +1? That means it's going to be horizontal shift, but it's always opposite if it's in the parentheses. So it would shift this way. Where is it? The original. 0.01 should be. Yeah, it's one of these. A or B, can't tell from here. Yeah, let's say B. +1, so it should be shifting this way. To the left. Okay. And then here they test you, do you remember the ideas of transformations? So if they give you a random function, and you shift it upward 1 unit, and you shift it down 4 units, what would you do to make that happen? Okay, you would just add a +1 on the outside. 8 to the x +1, 8 to the x -4, because it's down. The left and right would be inside the power, right? All right, I think that's enough for exponentials. There's some exponential equation at the end. Maybe we should look at those. Got about them. Yeah, here. Do a couple of these on paper. Solving exponential equations requires logarithms. It's kind of like when we had, it's the same idea as when you have a square root. You want to get the x out, you would square it, right? Because that is the inverse. When we were solving for sine, cosine equation, we would bring in inverse sine to get the x out. Same thing. So now you have exponentials, so you bring the opposite in, which is logs, and you get the x down. All the same thing over and over again. It's just different types of functions, different inverses. Okay. So number 1 here. 2 to the x -10 equals to 1. So what I recommend is just introduce a logarithm on your calculator. I choose ln every time just because it's my favorite. Doesn't really matter. The first step is introduce a logarithm of your choice. The next step is now that we have logs, we can invoke all the properties of logarithms. So I can bring down the power using the power rule back from college algebra. Once it's down, just solve for x. You just go back to basic algebra, solve for x. Okay. Step 1, bring in logs. Step 2, use log powers or properties. Step 3, solve for x, because now it's available to do basic algebra. Okay, so right now there's an x -10 times ln2. Just distribute the ln2. So it'll be x times that, right? -10 times that. ln1 though is, actually, if you plug in 1 into any logarithm, it will always be 0. So let's move over the 10. Again, we're just doing algebra, nothing fancy. add both sides. 10 ln2. Divide both sides by ln2. So x is equal to 10. In this case, the logs didn't really matter, did it? Canceled out. Double check. So it came out pretty because that ln1. It's the only reason. Usually there's like ln stuff left over. This like never happens. Okay. So the general idea is this. We do one more of these type, then we'll move it to a different type. And hopefully we'll have time for the log stuff. Any questions on example 1? It's okay. You guys remember? Oh, wait a sec. Yes, sir.
If I'm excited, but then it feels like something like the changes, like it's and then like 12.
Yeah, let's say it's ln4. You have an ln4 future. You would add this. It's the ln4 plus 10 ln2. Can't combine those. Then you just have that weird stuff divided by ln2. With the spirit, but you don't. It's that's right. Let us pretend. Yeah, it's gonna happen in the next question, but now let's say there was an ln4 over here. And I added the what's it, 2ln? No, 10ln. You'd have that on the right side. Then I would be dividing by ln2. Nothing will cancel. So the end result would be this. If it wasn't 0, you'd have plus ln2. You can't cancel those. Not true. You only cancel things that are factored. If I had ln2 on both, this guy and that guy, then you would cancel. Okay. Only cancel if you have products. It's only time. I do not have a product up top. Factors. Like, for example, I could not cancel these, correct? But if I had a factor, then it can. So if I were to factor ln2 on the top, then it cancels this ln2, but it cannot, right? There's no ln2 on top. The only factors cancel. It's only time to cancel. If you're able to factor something, then do it. Okay. Let's do another one. E to the R plus 15 minus 5 equals -30. So I know there's an E. I need to get that R plus 15 down. But before you introduce logs, you want to isolate the exponential piece. So I guess step one would be isolate the exponential part. All right, so add 5 to both sides. All right. Step 2. Introduce logarithms. And we do that to take advantage of log properties. Right? So ln of both sides. You see a problem though. While you're working on this homework, I would just look up all log properties if you've forgotten. Like I'm not expecting to have those memorized, but bring them up. Because there's a 6 or 7.
Is this to take what?
Oh. Yeah, I don't know what the hell that says, right? Advantage. Look like alien language. Do you see any issues here? Do you remember definitions and requirements, domain and range for logs? Yeah. Cannot have negative inside a log. You cannot have 0 either. It has to be above 0. So as soon as you're like, if you start solving this and you get to this point, you should automatically stop and say, you know what? There is no solution because this cannot be done, right? Then the homework, you say no solution. But if it would have worked, you would have ln and e are opposites, they're inverses, so they would have canceled. You would have had r plus 15 already ready to go. It's pointless here. Okay. Let's do something else. Maybe the next page. You guys cool on this page? Let me know otherwise. So same stuff, except it is, or I'm hoping that you see that this is quadratic in form. It has quadratic form. Yeah. Do you agree that this is the same as 6x? Yeah, I rewrote the first term. Agree this is the same. Power to a power is, the rule says you multiply them, right? So 2 times 3 is in fact a 6. So I am doing that just so you can see that this is a quadratic. If you still don't see it, let some random letter variable equal E3x. So if I replace everything with a W, do you now see that it is a quadratic equation? That you solve many times. Right, these types. So I don't know if it was obvious here or here, but not for sure, right? You just do your basic factoring. Does this factor pretty? Or do we need quadratic formula? What are the numbers? Yeah, yeah, that's right. -10 plus 2, multiplying gives you -20, add them gives you -8. So yeah, we're good. The next step for quadratic says set them to 0, solve for W, but W was made up. We're actually solving for X, right? We use substitution to make this easier. Right away. The problem is, wait here. Is that possible? Never negative, right? We had that picture earlier. Above zero. There's no solution. And if you didn't see that, so you bring in the logs, you have a negative inside the log. Well, the work that you would do, let's pretend we knew nothing about exponentials and we forgot domain and range. What you're supposed to do is introduce ln on both sides for both of these equations. But right here, you should see this is no solution. You cannot plug in a negative. That's like trying to square root a -1 or a -4. It's not real. A complex number. Okay. But this one does have a solution. I don't want to write no solution right here because it's like I'm talking. So ln and e are inverses and they have matching bases, so they cancel, giving you just the exponent. So x is equal to ln 10 over 3. That's it. Any questions on this type of exponential equation? So if you cannot isolate the e or whatever exponential you got, it might be a quadratic type, so approach it this way. But if you can, well, isolate it, introduce logs, solve for x.
So, right, it's like equal to L and which is like, or it's like if you get a type of log is
Okay, ln is the base of ln is base e. So some of the definition I'm going to have out right now. Log base a of a to the x, these match. We're going to cancel into x. Also, a to the log a cancel, giving you x. These are inverse of each other. So the bases match. The bases matched here. And they're going to cancel. Because ln means, by definition, log base e. It's just a shorthand. Nobody ever writes this because it's weird. So e is a special number like pi. It's like it's 2.17 or 71. So yeah. If you see if they don't write anything, then that's understood to be 10. This is a common log on your calculator. If you look at your calculator, there's a log button. That's 10. Like the square root is root 2, but no one writes the 2. Nobody writes the 10. Nobody writes the e. It's just convention. So shorthand. Yeah, I mean, you can always pick a base that will cancel it, but it's best to pick a base that is on your calculator. Thankfully, it was an E anyway, and it didn't matter. But let's say this was, I don't know, 2 to the 3x. And I brought an ln, they won't. But I have to bring the powers finally get it before, and then solve that. If you forgot and brought it down, they would pretty this. Okay, that's all for exponentials. Let's quickly look over logarithms. There's a whole section on logs. Yeah. Okay. Here they just want to use the definition. Let me get the definition for you. Oops. All right, here it is, I think. One moment. Oh, here it is. We'll come back to that in just a moment. So the following is equivalent. So given that X is an element of the real numbers, A and Y are both greater than 0, and A is not equal to 1. You cool with this notation? I always forget if I use it here. Epsilon. No. It just means X is a real number. Yes. A and Y are greater than 0. Both of them. Except A is not 1. So given all those things, the following two things are equivalent. A to the X is equal to Y is equivalent to, this is a double implication arrow in logic, log base A of Y equal to X. So the beginning of the homework, they want you to apply these definitions. So they're saying, okay, here's a log, change it to exponential, or here's an exponential, change it back to log. You can always go back and forth whenever you want using this definition. Just make sure you put stuff in the right place. Okay. A is always the base. Base of the exponential, base of the log. The argument Y is what this is equal to. The power is what this one's equal to. That's it. Okay. Again, there's a whole list of, I'll probably go ahead and send it to you later, all the quantum algebra properties in case you don't have them or forgot. I'll just send it to you. Because I'm not going to make you write a bunch of stuff, especially things you've done before. Yeah, where is it? Here. Yeah. So just change this guy. So given that note we just wrote, right? What would the answer be? Change to exponential form. I'll just switch up in a second. Is that a G? I guess so. Okay, whatever. What is that an exponential? The base is A. So you would say A to the X, which is what this is equal to, right? X. And is equal to Y, which is the argument. Oops. My bad. It's not 8. This is G. So it's log form, exponential form. So the homework will start out just making you go back and forth. Okay. Any questions on using the definition? It's not too bad, right? Is that down mouse? Oh, right. So you can see number 2, same deal. Exponential log, number 3, same. Same. After the first 5 or 6 questions, they start asking you to solve for something. So you'll go change it, use the definition to change it, and then solve for X. Yeah. Eventually it'll get a little harder. Here they're just testing your own properties. Remember we said you plug in a 110 log, it's going to be 0. If you're, so here's them testing you. If the bases match, we said they cancel, right? Giving you whatever is on the power. So, although what is that 0 going to do to 100? It turn to a 1, and then 1's inside the log, which is a 0. This would just be 0 times 2, right? This is ideas of just the definition and of the functions themselves, the graphs, the main range. I'll send that to you. That's really it. Let's see if we have time for one of these types of equations. So I guess let's just, let me give you the general strategy. You forgot. When you're solving for a log equation, the goal is to combine all logs into one and have a single log on one side or a single log on both sides. That's the goal. Once you've done so, then you introduce exponentials to cancel the logs. So right here, it's already a single log on both sides, right? So you just got to introduce the inverse of ln, which is e. That will cancel the entire logs. Here, they're not combined. You have 2 logs on the left and then a single one on the right. To combine these first and then bring in e to cancel. Same thing here. Here they're separate, so you have to combine them to a single one. So we have properties. The product property tells you if you're summing 2 logs, they become a product. If they're subtracting, they become a quotient. Here you can just let straight up isolate. Okay, so let's do this one. Let's see. You have time for this. This is about it. Two. Just make sure you have all the log and exponential properties on hand. This goes to ln minus x. Okay. So this is the way I want you to do it. And from my experience, it's the best way, but you don't have to do it this way. As long as you use legit math, I don't care. Combine all logs on both sides into a single log. On each side. So we have a minus, so we're gonna get ln of x plus 2 divided by x because of the quotient property. So if you subtract logs, they turn into quotients. If you add them, they turn into products. Okay. There's a bunch of these properties. Once you have a single log on the left and a single log on the right, like this, introduce a base that'll cancel both logs. Okay, so the base that matches ln we said is e. So introduce e on both sides. So step 3, or 2, sorry. Introduce a base on both sides to cancel the logs. And the property that we are using is this one. If a to the x is equal to b to the y, I'm sorry, that would be the same base. A to the x equal a to the y, that then, if that is true, that means x is equal to y. Actually, both directions. You can say it this way if you want, since I wrote it wrong. So there's a double implication logically. I can go from A to B, B to A. Same thing. Okay. It's technically an if and only if statement. But since I didn't write that, I wrote 2 separate if statements. Okay. You studied logic, you know what I'm saying. If not, just treat them as 2 separate formulas or definitions. The next one. If log base a of x is equal to log base a of y, then x is equal to y, and the opposite is true. There's also an if and only if statement. So this is what allows me to introduce logs on both sides whenever I want. This is what allows me to introduce exponential bases whenever I want on both sides. So these 2 separate things. Okay. So anyway, bring in the e on purpose. On both sides to cancel the logs. So this, the first 2 allowed me to do this. But technically, it's, they're both related. It's 2 sets of statements. Once you're here, it's just basic algebra again. Cancel logs, solve for x. So multiply both sides by x, that'll give us x plus 2 equal to 50x. That'll give us 2 equal to 49x. X is 49 over, no, 2 over 49, right? Whatever that is, who cares? All right. Algebra's whatever. But in a nutshell, that's what you want to do. You find all logs on one side. If there's no log on the other side, that's fine. As long as you use this next step. Introduce a matching base, cancel your stuff, and then solve cracks. If there's still logs that remain, it's okay as long as all the x's are free. And you just isolate the x, you're good. Sometimes you might have like x equal to ln2 plus ln7 or something weird. But just remember that all that crap is a number. ln7, ln2, and whatever. They're just decimals. Yeah, I'll send you all the properties because there are too many to write, and I don't have a lot of time. But yeah, I will. All right, let me take roll and we'll call it here. And I'll see you on final exam day, I guess. Yes. I'll try to give it to you on, I guess, the last day. I did not bring them. But yeah, I will. If those, they should be updated on your on Canvas sometime soon.
When will all her homework, like all this?
All homework is closing tonight, except the stuff we talked about today. And I'll close tomorrow.
So the two that we went over today was tomorrow.
Yeah, I could give you some more time if y'all want, but I think that I have to be unofficial because I think today's the last day I can really assign things or have due dates, right? Is that the official rule? Officially, St. Mary does not allow due dates past today because tomorrow and the day after are study days. So I can leave them open and pretend I saw nothing if you want. But
Could you do that?
just keep in mind, that's the official rule. Yeah, but if you need to finish a few things, I'll leave them open. Okay. So it doesn't matter to me. Just don't get me in trouble. Sadie? Jadlyn? Ava? No. Andre? Zoe? Aaron? Michael? Alexandra's not here. Juan? Juliana? Epifania? Andrea? Kimberly? Diego? No. Teresa? Hunter? Melica's not here. Connor. All right, guys. I will see you. What day did we say final was?
Next Monday.
Let's double check one more time. Exam is on the 8th, 8 o'clock in this classroom. So May 8th, 8 a.m. here. Next Monday.